All right, in this video, we're going to work through one more example about function transformations. This one is the most complicated one. It involves quite a few transformations, and in particular, it involves uh, a vertical shift and a vertical stretch or shrink. So, in that case, you have to be a little bit careful about the order in which you do these things. So the order will definitely matter here, and so so you're better off doing the vertical stretching first, this -4 or these four here, and then doing the vertical shifting later. Okay, so let me take one look at this and make sure that okay. All right. So not that one, but here. All right. So we want to get started, and so what we're going to do is, again, just like all these problems, imagine that we're starting with y equals f of x, and what we want to do is apply a sequence of transformations. These 6 transformations that we keep talking about. And what we want in the end, right, we're going to apply these one by one. And then in the end, we want to wind up with this one right here, this transformed function. Okay. All right. So let me make sure I'm doing it in the order that I have written in these slides, because otherwise it's harder to explain that way. Now, you can do it multiple different ways. Okay. All right, so the first thing that I'm going to do is I can see here I have x plus or minus a number on the inside. That's this transformation right here. So what I'm doing is replacing x by x minus 1. All right, so you can see I have this f of x minus 1 in there. That looks good. And then now what I'm going to do is I have sort of a choice. Do I want to go with this 3 here, or do I want to go with the 4 and try and get the 4 on the outside? And here we're going to be way better off if we do the 4 first, right? So one of the transformations is that I can multiply a function, right? The function by some value for k. So that is exactly what I'm going to do. The k needs to be positive, right? So I am going to go ahead and do that first. So I'm going to go y equals 4. I'm going to multiply the entire function, right, by 4. So I'll have 4 times x minus 1, like this. Okay. Now, you might say, well, how is that any different? Why can't I just do the 3 first and then do the 4? All right, let me go ahead and do the 3 first. Or actually, I don't even want to do the 3 first. I want to get this as a minus 1 first. So let's go ahead and keep working through this in the correct way, and then I'll show you why it's important to do this 4 first. Or to me, it's easier if you do the 4 first. All right, everything's looking good. I have this 4 times f of x minus 1. And so again, the next thing I'm going to do, this is actually a negative 4, so I am going to apply this transformation, this one here, where I multiply the entire formula by minus 1. Okay, so I'm going to do y equals minus 4 f of x minus 1. All right, and so you can see I'm a little bit closer, right, to this. And in fact, the only thing I have left to do now is this 3. And if you look at that transformation of the 6, it's this one right here, where I'm just adding a number to the function. Okay, so I get y equals minus 4 f of x minus 1 plus 3. Okay, like that. And you can see I am where I need to go. All right, so I figured out, okay, starting with y equals f of x, which transformations can I apply to wind up at this one? Which of the 6? Okay. So now I said, hey, it's right at this point, I said it's better to do the 4 first and get that there and get all that stuff straightened out than to do the 3 first. And let me show you why. All right. So let's just say I had done the 3 first, right? Okay, so I had done the +3 and got that first, and then the next thing I would have had to do would be to do this 4, right? So if you look at this transformation right here, it's k times all of f of x, okay? So this represents the entire right-hand side. So if I multiply this entire right-hand side by 4, because that 3 is there, right, the entire right-hand side would have to go in parentheses like this. X minus 1 plus 3. All right, and that means that this 4 would have been distributed to the f of x minus 1. It would have been distributed to the 3 as well. So in reality, what I just did, right, by multiplying the entire right-hand side by 4, this is now equal to 4 times x minus 1. That's looking pretty good. But this 4 also has to be distributed to the 3. So I wind up with a plus 12 like this. And that is not good. I don't want that, plus 12. Now I could fix that, right, by subtracting off the right amount here. But you know, if I just subtracted 9 right here and did another vertical shift, I could get this back to a 3. But that's a lot of, it's just, you're creating more work for yourself by doing it that way. All right, so if it has this combination of vertical stretch or shrink and a vertical shift like this one does, to me you're better off just doing that vertical shift at the last here. And now it definitely depends on what other things are going on, right? So the main point here is that the order matters. I wouldn't do it this way, although you can. It's just kind of going the long way. All right, so here are my sequence of transformations that I made on the graph, and I have those written down here. Okay, so I started with y equals f of x, right, and then I applied these, and I wind up with the function that I want to. In each case, right, I identified the k, right, so k is 1 here, it was 4 here, right, and no k for the reflection. And here I identified this. So I end up with these graph effects, right? I know that this is a horizontal shift right. I know that this is a vertical stretch. I know that this is a reflection about the x-axis, and then this is a shift up 3 units. Okay, but really on the Newton problems that you'll have to work and on the test, it's better to look at the pointwise effect. What happens to the points. And so just to give an example of how that would go, let's say that on y equals f of x, let's say on y equals f of x, I had a point that was 1, 2. Okay, there's a point on y equals f of x. Then what I would do is go through these series of transformations, right, step by step, and figure out where this point would go. All right, so what I would do first is add 1 to the x value. So that point would have gotten moved to 2, 2 by this transformation. And then multiply the y by 4, right? So that would have gotten moved to, oops, that's going to be 8, right? So this point I would multiply the y by 8. All right, this transformation would change the y value to the opposite, so it would be minus 8 instead of 8. And this one would have added 3 to the y value, so 2 plus, or to the y value, so negative 8 plus 3 would be a negative 5. All right, so this point would have gotten shifted, the point at 1, 2 would have gotten moved to 2 minus 5 by making all of these transformations. Okay. All right, in the next video, we are going to work through some of the Newton problems so you can see how that goes and how all this would be applied in that.